So, the first thing that we need to know about soil structure is that soil contains a mineral portion and can be divided into three main particles based on size: sand, silt, and clay. Most soil consists of a mixture of these soil particles, okay? And every single particle of clay, silt, and sand has like a specific diameter. For example, the particle diameter of clay is less 0.002 millimeters. Silt is between these amounts, 0.002 and 0.05 millimeters, and sand is a little bit bigger, so 0.05 to 2 millimeters, as you can see. This is a soil triangle. There is a video that is going to explain you how to use it to see, depending of the percentage of clay, sand, and silt, what is the type of soil. As you can see in this triangle, we have soil that is just clay, sandy clay because it has a mixture of that, sandy clay and loam, sandy loam, loamy sand, silt loam, silty clay loam, and silty clay. So these are the types of soil that we can find in this planet that are used in agriculture, and which is the percentage. Why is so important to know the percentage? Because that way different species can grow in those soils. And also the portion of each of these particles gives soil its texture. It's very important to know that when you get soil or you rub soil, sandy soils, we have different characteristics. For example, sandy soils are gritty and fall apart easily. Silty soils feel slippery, like wet talcum powder, and hold together better than sandy soils. Clay soils feel sticky and can be rolled up into a ball easily. So those three are very different. You have pictures in the platform to identify them. This is the composition of three different types of soil and the comparison of these three types of soil. We have sandy soil, clay soil, loam soil. Which are the characteristics that we're going to see? What is the composition of sand, silt, and clay that all those soils contain? Also the mineral content, the potential to hold organic matter. When we say organic matter, it's living matter that is in a state of decomposition, or everything that is made of carbon, carbohydrates, sugars, and any kind of matter that contains carbon. Drainage, water holding capacity. What is the amount of water that soil can hold? That is part of the virtual lab to understand that. Air spaces or pores, biota, and primary productivity. When we talk about primary productivity, is how species gain mass and energy from soil, right? So as you can see, sandy soil, the composition is 100% sand. One example is, for example, the deserts of the beach. And we have that the mineral content is high because it contains sodium chloride and other types of minerals. Also, the potential to hold organic matter is low. Drainage, very good. Water holding capacity low. Remember that we are talking about sand. Air spaces are large. Biota is low, and primary productivity is low. When we talk about clay soil, the composition changes. Okay, so 15, 15, and 70 of these composition parts. And in loam soil is 40, 20, 40. 40 of sand, silt, and 40 of clay. So mineral content is high in clay soil and is intermediate. Potential to hold organic matter is low, intermediate. Drainage poor, drainage is good. Water holding capacity is very high in clay soil, intermediate. Air spaces are small and intermediate. Biota is low and high. Primary productivity quite low and high. So which is the best soil to produce, to have a production of plants? Loam soil. Also is used in agriculture. When we talk about porosity, permeability, and pH, the most important thing is to know that related to a soil texture is the amount of space between particles in porosity. You have pictures also in the platform to understand this. And the easy and the ease and which gases and liquids can pass through the soil is called permeability. That is the most important thing that you need to know about that. And the last, soil sustainability. Fertile soil is non-renewable resource. Once it is lost, it cannot be replaced quickly. It takes like a year to repair. to repair soil. Okay, soil formation takes a very long time. Also, one important thing that we have in here is that we know that the soil is fertile when we have nitrates, phosphates, and potassium, NPK, minerals, water, the porosity is okay, the water capacity also is okay. So that soil is fertile and it has enough nutrients for healthy plant growth. As you can see in this picture, we have like some of the nutrients are used for different parts of the plant. Potash for flower head or fruit, in this case is potassium. Nitrate for leaf and stem. Phosphates for root and for the root system, as you can see. Okay, in this two activity we're going to do it in class, and that's it, guys.